So let's take a look at overlaid histograms because these are also very useful. So here's a new data, a new data set. We're going to read this in. We see it's a table of, it turns out this is a table of child heights. So we have 934 measurements measured by this guy called Galton, Francis Galton. He, back in the 1800s, measured a bunch of, gathered a bunch of data about the heights of children and how that related to the heights of their parents. So every row here is for a child, and so some of the children are from the same family. So what you see here in the first column is the label of the family they're in. So these 4 children were from the same family. You have the height of their father, the height of their mother. You have something called the mid-parent height, which is kind of, but not exactly, an average of the two. It's a weighted average of the father and the mother height. You have the number of children in the family. You have which child this is in the family, so the first child, the gender of the child, and then the height of the child whenever they're an adult. So we have an idea that perhaps if mothers and fathers are, the mother and father are tall, the child will also be tall. And we can kind of get a sense of if that's true by looking at this data set. So what we're going to do is first extract only the columns we need to make our visualization. Because remember, whenever we dot plot and don't specify a column, it's going to plot all of the columns, and we don't want to visualize all of these columns. Maybe all we want to do here is visualize the father's height, the mother's height, and then the child's height. And remember, with a histogram, what we're doing is we're visualizing the distribution of these things. So how likely is it that a child is 70 inches tall, for example? We want to kind of plot like this distribution of the heights. So I want to do that for all 3 groups, the fathers, mothers, and the children. And I want to plot it all on the same figure so I can compare them. So our first step here is going to be to get rid of the extra columns. I can do that with drop by specifying all the columns I want to get rid of, but it's easier here actually to specify the columns I want to keep. And I can use that with .get if I pass in a list. So this is another way of using get. We've seen get to get a single column just by passing in the string, the column name, but here I can pass in a list of column names. You see what you get back is a new table with just those columns. So this is handy. This is very useful. So I've got my new table with just the information I want to plot. My next step is to .plot, tell it the kind. I want histogram. And then I'm doing some extra stuff here. Bins we saw before, that's how many bins I want to divide my data into. 20 is a 20 is a common choice. You can mess around and see what happens. Alpha.0.065, that's going to specify how opaque each of the bars are. So let's go ahead and plot it and I'll show you what I mean. So this is what we get back. I've got 3 histograms plotted on the same axis. I've got the distribution of the father heights, the distribution of the mother heights, and then the distribution of the children. So we can get a sense of what's going on or whether or not that intuition is true, that that children tend to be about the height of their parents. First of all, the alpha 0.65, if I go back and I change this to alpha 1, you see what happens is all of the bars are solid. That's 100% opacity, and this isn't great because I can't see what's going on underneath the yellow bars. So I changed this to something like half or 0.5, and that allows me to kind of see through and get a sense of what's going on. Sometimes it's easier if I make this a little bit more opaque, like maybe 0.75 is good. Okay, now what can I get from this chart? So first of all, I kind of get the sense that the child heights are kind of like an average of the height of the mother and the height of the father. And how do I see that? It's because I've got this blue curve here, right? That's the heights, the distribution in heights of the fathers. And what we see here is that is significantly higher than the heights of the mothers. which kind of follows our intuition. Males tend to be taller on average than females. There is some overlap here, right, where there are some females who are taller than some males, but on average, the two groups are separated. The children, though, they tend to be about in the middle. The distribution is kind of like right in the middle of these two groups. And we'll analyze this a little bit more, trying to see, do taller fathers and mothers make for taller children? But we can't exactly get that from this plot. We're going to have to do a more detailed analysis, which we'll do towards the end of this lecture.